Welcome to one and all. Coming to the video and automata theory. And today we are see the various topic of automata theory is finite automata and regular expressions, context-free grammars, push-down automata, finite automata and lexical analysis, basic parsing techniques. Now we are going to discuss about finite automata. And in this finite automata we are going to see what is finite automata and what are the representation of finite automata, and finally the types of finite automata. Right? Now coming to the definition of finite automata. So then is a finite automata mathematical model of digital computer. It is used to recognize patterns within input taken from some alphabet sets. It consists of discrete inputs and outputs. Input given to the machine is processed by various states. These states are called as intermediate states. The job of finite automata is to accept or reject an input depending on whether the patterns defined by the finite automata occurs in the inputs. That machine is nothing but a finite automata. And we can also say is a recognize. Why? Because so this and the possible string, it will say either yes or no, whether this input string is an acceptable one or not acceptable one. That is called as recognize. Now coming to the representation of finite automata. Generally there are three representation of finite automata: graphs like a transition diagram, and tabular, that is your transition table, and finally mathematical like a transition function. And coming to the mathematical model of finite automata. The mathematical model of finite automata consists of 5 tuples. Q is a finite set of states and sigma finite set of input symbols. And next one, del. Del is a transition function, that is Q into sigma tends to Q. And Q naught is start state, or it is called the initial state. And finally F. F is a final state or accepting states. So this is all the 5 tuples that are finite automata consist of, that are the representation like this. Finite automata are machine equal to Q sigma del Q naught F. Now we will see what are the representation and how it can be used. Right? So coming to the first representation, transition diagram. When say transition diagram, it is a discrete graph that consists of vertex and edges. So this vertex is actually used to represent these states, and we are using edge to transition happening between them states. As well as the transition diagram, the boxes of flow charts are drawn as a circle and called states. States are connected by arrows called as edges. The label of weights of edge indicate the input characters that can appear after the states. So this is an example of transition diagram. Sometimes start symbols as well as final state. And the main things, initial state is represented as arrows. Accepting states are represented by double circle. Then coming to the transition table. What is transition table? A transition table is represented by the following things. Columns corresponds to input symbols, rows corresponds to states, entries correspond to next state. The start state is denoted by the arrow with no source. The accepting state is denoted by a star. For example, let us take the sensor door. Is initially door is closed, then take the input string, someone is standing, and now this transition happening from next state open, and take the another string, no one is standing. Now the transition happening from next state closed. And the expansion of 5 tuples notations on this example is finite automata. Q is a open and closed, and sigma is no one is standing and someone is standing. A sigma is transition function, is a del open, no one is standing is closed, and del of close and someone is standing equal to open. Q naught is closed and F is closed. Thank you.